Good morning, students. In the previous video session, we have discussed about the time period for an orbiting satellite and the energy of an orbiting satellite. So, we have found the time period for the satellite to complete one revolution and the energy used while it rotates, the energy, total energy used by the satellite also we have found. But today we are going to see about geostationary and polar satellite. Sometimes when we look upward, we can see some of the satellite which is held stationary. When we look upward, we can see some of the satellites moving around. Night time and all, you can see some satellite very nearby our Earth and which is moving around the Earth. And some satellites you can see it looks stationary, it's not moving. We will see that it is at one place. Actually, why this is happening means by using the time period of an orbiting satellite formula, T-square formula, time period formula, if you are finding the height of this satellite is around 36,000 km from the Earth's surface. This is our Earth. So around 36,000 km distance this satellite is held. That's what when we look at these satellites, it looks stationary. Such type of satellite only we are saying geostationary satellite. So this is the reason you see from the Earth's surface this satellite is orbiting around the Earth which is at a 36,000 km distance. This is what very far from our Earth's surface, which is it is around 36,000 km. That's what it looks stationary. So such type of satellites only we are saying geostationary satellite. And in India, our INSAT group, INSAT satellite group, Indian National Satellite. That is what INSAT group. They use different these two types of satellite: geostationary satellite and polar stationary satellite. This geostationary satellite, which is held at a distance what is 36,000 km and mostly used for the purpose of telecommunication. We know that now telecommunication is very easy, fast for us. Anywhere you can contact, in any country you can contact within a minute and all, without any lag. So it is, so for such type of communication, telecommunication system and all, we use India INSAT group satellite to use this geostationary satellites. So geostationary satellite means what? You can see in page number 26, one small definition. They appear to be stationary when seen from the Earth. It is one of the important 3-mark question. Geostationary satellite and polar satellite. You have to just write the definition and geostationary satellite. They appear to be what? Stationary when seen from the Earth. It is around 36,000 km from the Earth's surface. You have to write, and it is used for telecommunication purpose. Like this 3 point means you get a mark. So what are things you have to write? The geostationary satellite, they appear to be stationary when seen from the Earth. First point you can mark in the textbook. in the page number 26, they appear to be stationary when seen from the earth. That is geostationary satellite. And purpose, what is the use of it? For telecommunication purpose, and it is around 36,000 km from our earth surface. And the next type, the other type of satellite is polar satellite. Polar satellite, if we are saying about this polar satellite, this polar satellite orbiting around the earth from pole to pole. Pole to pole means this is earth. From north pole to south pole. From satellite is held like this. Satellite is held like this, and it moves like this. From one pole to another pole. Then this pole to here. Then this pole to here. Like this, it covers the distance. It covers what? A small area of strip. In one rotation, it takes 100 minutes to cover our earth. It means in a day, in one day, it rotates. This polar satellite rotates several times. That's what I told you. Night time, evening time, you look upside down. You look the sky, you can see the satellite which is moving around. That is this type of satellite, polar satellite. It is held at just 500 to 800 km, and polar satellite means what? Yeah, it covers, it orbiting the earth from north pole to south pole, north pole to south pole, from pole to pole. So each pole, in this pole to pole means what? It covers first one strip of area, one area of strip, then another strip of area, then another strip, then another strip, then another strip. Like this, within 100 minutes, it covers the whole surface. And one time it covers one strip, and another time different strip it moves. That is what a polar satellite. So you can write about this polar satellite 3 point. What the first thing is, polar satellite means what? It orbiting the earth from pole to pole, from north pole to south pole of the earth. And the second thing, it is held at a distance of 500 to 800 km. And third thing, it covers what? How it covers? Yeah, it covers pole to pole. Pole to pole in the area strip. So like this 3 point you are writing means you will get the 3 mark. So the page number 26 and 27 it is there. Page number 26, first you have to write about the geostationary satellite. They appear to be stationary when seen from the earth, and what it is held how many kilometers? 36,000. Then use telecommunication purpose. Then here you can tell what this polar satellite. In page number 27 you can see third line, satellite that orbit the earth from north pole to south pole is called polar satellite, and it is placed at a distance of 500 to 800 km from the surface of the earth, and the time period, how much time? 100 minutes. Then you can write how it cover means polar satellite cover a small strip of area from pole to pole during one revolution. This was the thing you are writing means what? You will get a 3 mark. Why it covers strip to strip means there is a thing we know that the earth is not a straight, it rotates some 23.5 degree angle difference is there. You can see the globe and all, it is not held straight up, just slanting. It is some angle is there, 23.5 degree angle. It is what about the geostationary and the polar satellite. Now next thing is weight. Next topic is new topic, weightlessness or weight of an object. And then first thing, a short answer question is there, weight. Weight of an object means what? Assume that weight of this object. Weight of this object means, you see, there is a downward force which is acting what? A force which is acting downward direction. The same magnitude, in the same size, there is a force also acting upward direction. That is what we are saying, normal force. So, if the object is rest or it is moving, this both the force which is acting upward and downward with the same magnitude. That is what we are saying, weight of it. You can see in page number 27. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10th line. That is on 2 mark definition. The weight of an object W is defined as the downward force whose magnitude is equal to this upward force that must be applied to the object to hold it rest at constant velocity relative to the earth. So weight means what? Weight of an object means W, you can use the symbol, and it means what? It means there is a downward force which is acting in the same magnitude of the upward force when it is at rest or in moving in constant velocity relative to the earth. And we use the equation W equal to mg. Okay, W equal to mg. That is what weight of equation. W equal to mg equal to n also you can use. Weight means what? Downward force mg is equal to what? The normal force which is acting upward or equal. Now next is apparent weight of an elevator. Apparent weighted elevators. We all have the experience of what are moving in lift or elevator. Sometimes we felt that when we are standing inside the lift, when it stops or starts, there is a jerk movement like this. We feel that we are going to fall. What is the reason this is happening? First thing, apparent weight. What is the meaning of this apparent weight and the actual weight? First, you have to know the difference between apparent weight and the actual weight. Actual weight means this weight, downward force and upward force. Weight which is acting downward and normal force which is acting upward, both balance means that is the actual weight. Apparent weight means if this downward force, gravity is acting downward, normal force is acting upward. This gravity acting downward force and the normal force which is not balanced means that is what we are saying apparent weight. So here we are going to compare this apparent weight and the actual weight. Because of this apparent weight, it is the reason why we feel a jerk moment when we stand inside this lift. So we can assume that you are standing inside the lift. When we are standing inside the lift, there are two forces acting on you. Assume that you are standing or I am standing inside the lift. When we stand inside the lift, there are two forces which is acting. The first one is gravitational force. And the second one is normal force. So when we are standing inside the lift, there are two forces acting on it, acting on that person, or you are standing means on you. These two forces are acting: gravitational force which is acting downward, and the normal force which is acting upward. Gravitational force which is acting downward means what? This direction. This is in minus j vector, so minus mg. So gravitational force which is acting downward, F g, you can use gravitational force. Fg is minus mg j unit vector. By using the vector in this question, we use the vector. You see, mg is acting downward, that is in the minus j direction, j vector direction. So mg minus mg. Now normal force, so minus mg. Normal force which is acting upward, this is minus j vector, this is plus j vector. So here n is equal to what will come? N positive vector. So this we can write down. N is equal to n j unit vector. N is equal to n j unit vector. So downward minus mg j vector and upward normal force. So these are the two forces acting when you are standing inside the elevator. So when a man is standing inside the elevator, two forces which is acting on him, a gravitational force and a normal force. Gravitational force which is acting downward in the j vector direction. So W is equal to minus mgj, you can use, and the upward force, normal force which is acting upward, so n is equal to mj vector you can use. Now we can consider some cases and we can find out this apparent weight. We can compare this apparent weight from his actual weight. For that, first case is when the elevator is at rest. Case 1. When the elevator is at rest. Now we will see what will happen to this gravitational force, what will happen to this normal force, and what happened to him. When a person is standing at rest inside the elevator, what will happen to the acceleration? Acceleration is 0, no acceleration. So his acceleration is 0. So when we are applying the Newton's second law, F is equal to ma. This a is 0. So what will happen? This stamp will become 0. Okay, what are the total forces acting? F, G. So this is 0. Fg plus normal force Fg j vector. Next we can use n is equal to 0. This is the total force. The gravitational force which is acting downward, normal force which is acting upward. Acceleration of the person is 0, so this term becomes 0. Now what is Fg? Downward gravitational force minus mg j vector plus n j equal to 0. This is substituting that down. Now comparing the component. Comparing the component means just we have to remove the vector symbol. So minus mg plus n equal to 0. N is equal to mg. This minus g go after equal symbol, so minus becomes plus. So n is equal to mg. So n is equal to mg is equal to weight, polar same. It means the apparent weight and the actual weight is same. This is the first case. So when a person is at rest inside the elevator, his apparent weight is equal to his actual weight. Now the case 2 also same. Case 2 is when a person is inside the elevator, but assume that it is moving uniformly. Uniformly means constant velocity, not accelerating, not decelerating, just moving in uniform speed. That is the second case. When the elevator is moving uniformly in the upward or downward direction. It is moving upward or either downward direction, but uniformly it is moving. When it is moving uniform direction, what will happen? The same thing, its acceleration will be 0. So the apparent weight and the actual weight of the person inside the elevator is equal. The same thing. Rest also, uniform motion also, same thing. And the third one is case 3, when the elevator is accelerating upward. Case 3, when the elevator is accelerating upward, assume that elevator is accelerating upward. This is a vector. Here minus j vector plus j vector. So minus elevator is accelerating upward. So ma is plus. Accelerating upward. So applying the Newton's second law, F is equal to ma. There is an acceleration, accelerating upward. Now total force is Fg plus normal is equal to ma. What is gravitational force? The same gravitational force which is acting downward. So minus mg j vector plus normal force upward. Normal force upward plus j vector equal to ma upward plus j vector. Now comparing the component, just remove all these j. And you can write mg plus n equal to ma. Now rearrange and write n is equal to this minus mg, take this side, so plus mg plus ma. Here m common, take this m outside, so n is equal to m into G plus A. So here apparent weight is greater. That's what I told her. Apparent weight and actual weight. Apparent weight means both gravitational force and normal force not balanced. Here normal force and gravitational force is not balancing. Some additional thing is there. So apparent force is greater than what? His actual weight. So apparent weight is greater than actual weight. Now case 4, the last case, when the elevator is accelerating downward. Now assume that the elevator is accelerating downward. What will happen to the apparent weight from his actual weight? Now you see, apply Newton's second law, ma. Lift is moving downward. So downward direction means ma also downward direction. And mg downward. Minus j. Only normal force upward. Normal force. Now not balancing. Before also, here also same thing. You see here. Case 3. Lift is moving upward. When the lift is moving upward normal force acting. Upward what is acting? ma. Normal force. Downward only what are? The same thing here. MA acting downward, MG acting downward. So here also apparent weight is not balancing. Apparent weight is, now what we will see? We will see what will happen. It is greater or less. To the calculation, what is the total force? Fg plus M is equal to MA. Fg means minus Mg J vector plus N J vector Ma here equal to minus M. So minus Ma J. Now comparing the components, remove this J. So minus Mg plus N is equal to minus Ma. Now take this minus Mg this side. So N is equal to Mg minus Ma. Now N is equal to, take M outside commonly, M into G minus A. Now apparent weight is lesser than, his actual weight. These are the four cases. So students, listen here. Apparent weight in elevators, we are considering four cases. First case is at rest. There what is happening? N is equal to Mg. Apparent weight and the actual weight balance. Both are same, equal. Now next case we are taking the same uniformly moving. Uniformly moving means constant velocity, not increasing, not accelerating, not decelerating. So the same thing, apparent weight of the man is equal to his actual weight. And the third case here, third case is when the elevator is accelerating upward. Elevator accelerating upward means A is equal to what we will get down? A is equal to A J vector. So positive direction. So finally you will, total force is Fg plus N is equal to Ma you can use, and the total force here. Gravitational force is acting downward minus Mg, and the normal force which is acting upward J, and this one acceleration also upward, so Maj. Now minus Mg, take this side, commonly take M outside, so M into G plus A. So this is the third case. Now the apparent weight of the man is greater than his actual weight, and the last case is same thing. You have to find out the total force. Gravitational force is Mg and the normal force is N only. But it is going downward, so the acceleration. Now acceleration in minus J vector direction, so it becomes what? Minus A. Now we are taking this Mg this side, so M is equal to Mg minus Ma. Now M we take commonly outside M into G minus A. Now we can write the condition what? Apparent weight is lesser than his actual weight. So take page number 28, apparent weight in elevators. You can start from the third line. 1, 2, 3, 4, fifth line. Let us consider a man inside an elevator in the following scenarios. When a man is standing inside the elevator, there are two forces acting on him. 1, 2, then all the four cases until page number 21. Apparent weight W equal to N is equal to M into G minus A of the man is lesser than his actual weight. You can just go through that, just go through this. And in this video session, very important part is geostationary satellite and polar satellite. Then the definition for weight of an object. So, dear students, all of you practice this, just go through that and study clearly the polar satellite and the geostationary satellite. It is an important question. And see you all. Bye bye. Thank you.